Okay, in this video we'll move on to the second most important thing we learned in this section, and that is how to determine whether an equation has one solution, no solution, or infinitely many solutions. And we'll see what happens in different cases. Let's start with number 19, and that says that 3t plus 4 is equal to 12 plus 3t. Now this might appear to be problematic right from the beginning because we have 3t on both sides. Now obviously 3t is the same as 3t, but on one side we're adding 4, on the other side we add 12. So how could 3t plus 4 be the same as 3t plus 12? Now we can show one step further that we're going to have a problem here by collecting the variables on one side. We would do that by subtracting 3t from both sides, but when we do, we end up with 4 is equal to 12. And that's a problem because 4 is never equal to 12. So we say this is never true, and since it's never true, there are no solutions. So how do we know that we have an equation for which there are no solutions? When we collect the variables or attempt to collect all the variables on one side by adding or subtracting a variable quantity from both sides, we end up with all the variables disappearing, and instead we have one number is equal to a different number, and we know that that cannot be true. And so no matter what we plug in for the variable, in this case t, the left side 3t plus 4 will never equal the right side, which is 12 plus 3t. We'll go on to the second example, which is number 21, and that says that 2 times h plus 1 is equal to 5h minus 7. So here we will need to distribute on the left, and we get 2h plus 2 is equal to 5h minus 7. At this point we can choose to either move variables to the left or to the right. I'm going to just use the same principle of moving the variables to the left. And when I do this by subtracting 5h from both sides. When I do, I get negative 3h plus 2 is equal to negative 7. At this point, I can subtract 2 from both sides, and I end up with negative 3h is equal to negative 9. Dividing both sides by negative 3. Remember to divide by negative 3, since that's what's multiplied times h. And I end up with h is equal to positive 3. Negative 9 divided by negative 3 is positive 3. So that's one solution. And what does that mean? It means that the original equation, 2 times the quantity h plus 1 on the left, will only equal 5h minus 7 on the right when h is equal to 3. Any other numbers will not make the left side equal to the right side. We'll go on to the next example, number 23. In number 23, we have 3 times 4g plus 6 is equal to 2 times 6g plus 9. In this case, we'll have to distribute on both sides of the equal sign. When we do, on the left, we end up with 12g plus 18 is equal to 12g plus 18. Now, this is the case where we're going to have infinite solutions because we have the same exact thing on both sides, whether it's variables and numbers, only variables, only numbers. we have exactly the same thing. It has to be exactly the same thing on both sides. No sign differences in any of the terms. So, since that's true, since that's the case, we say then that this is always true, and there are infinitely many solutions. Now, how can we tell the difference by looking at our answers? We know that there are no solutions when you end up with two numbers that are different from each other. We know that there is one unique solution when you end up with the variable is equal to some number. We know that there are infinitely many solutions when we end up with two expressions, one on the left and on the right, that are exactly the same, regardless of whether they're numbers, variables, or variables and numbers. As long as they're exactly the same, then there will be infinitely many solutions. Alright, at this point we're going to go on to the next problems in the homework set. And I will scroll down. And in these problems, number 25 and 26, we have some error analysis. So let's take a look at the original. The way we're going to work with error analysis is we're going to look at the original equation. And then we're going to look at what we would do and think about that, and then take a look at what the student or this person has done. So let's take a look and see what would happen. We start with 5c minus 6 is equal to 4 minus 3c. And here we see we have an equation with variables on both sides. And what we would do normally then is to, in our case, we would try to collect all the variables on one side. And the only way we can do that would be by adding a 3c to each side of the equation. Well, when we do that, we end up with 8c minus 6 is equal to 4. Now, let's take a look at what this student did. Instead of 8c minus 6 equals 4, they have 2c minus 6 equals 4. And can you see what happened? The student subtracted 3c on the left side, but added 3c on the right side. 3c was subtracted on the left instead of being added as it was done correctly on the right, or on the right side. Alright, so we have, starting with the initial equation and thinking about it ourselves, we can see what the student did incorrectly. They added 3c properly on the right side, but they subtracted it on the left, and so they came up with 2c minus 6 equals 4 instead of 8c minus 6 equals 4. All right, let's go on to the next, number 26. Again, we'll do the same idea here. We'll start with the initial equation, and then so we have 6 times the quantity, 2y plus 6 is equal to 4 times the quantity, 9 plus 3y. We want to distribute on both sides of the equal sign. And when we do, we have 12y plus 36 is equal to 36 plus 12y. Now, as we have said, when we get exactly the same thing on both sides. Well, it doesn't appear that we have exactly the same thing, but we do. They're just in different orders. And we could use the commutative property of addition to change the order of the things we're adding and to show that the sum, the result, would still be the same. So actually we have the same thing on both sides, and when we have the same thing on both sides, it means that we have infinitely many solutions. This is always true. Infinitely many solutions. So what happened was that the student confused the scenario where you have infinitely many solutions with the scenario where there are no solutions. No solutions, we need to have two different numbers equal to each other. Infinitely many solutions, we would have two of the exact same numbers added, set equal to each other, which we have here. 0 equals 0. That's always true. So we say infinitely many solutions was confused with no solutions, or we could say that vice versa. They chose no solutions, but it really should have been infinitely many solutions. Okay, and so that'll do it for this video. We'll go on to more of the word problems in the next video.